up to now, we have dealt with the so-called inner join. Yeah, and we have seen the specific effects that that kind of join has. And now we will learn a further join concept, namely so-called outer joins. And let's start with a motivating example. So the thing I would like to accomplish is to figure out who are the non-heads within the company. Yeah. So if we take all employees, these are those ones here. Yeah. And if we take a look at the heads, these are Lee, Miller, Ortega, and Sanchez. So the query, in order to figure out the heads, is would look as follows. It would look like that. I would say select last name from employee E join org unit. And now the join condition is on. The join condition now is going back here from the org unit to the employee, namely EID equals head. Yeah, the other examples have already used that connection here, OU org unit equals OUID, but now we take the connection the other way around, that's the head off, yeah. So the join condition is on, and let's call it OU here, OU, and OU.head, yeah, should be equal to E.EID, yeah, and let's call it E.last name here. Yeah. So if I do that here, then I get that result here. Yeah, and actually I get Miller 2 times here and Ortega 2 times because they are leads of 2 different org units. So in order to make that, yeah, so if we look at the data here, we see that here number 1 is head of 2, yeah, and number 4 is head of 2, and 4 is Ortega. Therefore, he is Miller and Ortega 2 times. We can solve that by introducing the distinct here, and then we have Ortega, Miller, Lee, and Sanchez, yeah, as the heads. Yeah, Ortega, Miller, Lee, and Sanchez. So the ordering doesn't matter. Yeah, the database system provides no specific ordering unless we introduce an order by. So this is the query for the heads. Yeah, and select last name from employee will give us all employee last names here. Yeah, so if we are now trying to figure out who are the employees that are not head, one might consider to just change the join condition from equal to non-equal. So from employee join org unit, where head not equals EID, yeah, in order to capture the non-heads. And that's meaningless, as we will see in a moment. So let's just do that here, yeah, and let's see what happens. And what we see here is oh, sorry, why do we only see 8 here? Is because of the distinct. So let's remove the distinct here first of all. And then you see 42 records here. Why is that the case? And let's add the OU dot, it's also called name, if I remember correctly. So for example, you see Sanchez connected with company, Lee connected with company, Ortega, and so on. And that's clear that it must that way because if you remember the Cartesian product, the Cartesian product, first of all, takes all combinations, and then it filters out those combinations that don't fulfill the condition. And the only combination that doesn't fulfill that condition is the Miller record, because Miller is head of the company, so he is not. So the head and the EID of that combination is the only one that doesn't satisfy the unequal. All others are satisfying the unequal. So for all non-heads we get one. For all heads we get 1, 2, 3, 4, 5, 6, 7 records, and for all non-heads we even get 8 records. Yeah, so that's that is happening because for all non-heads the connection is unequal for all records here. Yeah, for all here orgunits records an employee is connected to. Yeah, so it might be even, let's make it a little bit more clearer if I order that by order by e dot last name. Yeah, let's do it that way. So that's even better. So we see Krause here, and actually we have if we look at the data, we have 1, 2, 3, 4, 5, 6 orgunits. Yeah, so the what I have explained you before, I have said before, that was a little bit wrong. The idea was correct, but the example was wrong. So if for example Krause, yeah, Krause is not a head. So if I take all Krause records, combinations Krause record, of the Krause record with all employee records, for all of them, this inequality holds. Yeah, but if I take Miller, yeah, Miller is only 1, 2, 3, 4 times here because he is leading 2 orgunits, and for those 2 the equality holds, and that means the inequality that does not hold. Therefore, Miller is 4 times, and so on. Yeah. So joining with inequality, not equal, is almost always wrong. Yeah. Okay, but we would like to figure out how to are the non-heads, don't we? And so we need a way to do that. Since the head-of relationship, this foreign key, if we do an inner join, we only get via that relationship, via that foreign key, we only get the heads, and the non-heads, as you remember, are removed because they are not connected via that connection. Yeah, and therefore the inner join is not able to solve that. And now here comes the outer joins. So let's first try to understand what the outer joins are doing, and then let's figure out how they are able to solve our problem. Again, we have these 2 tables, R and S, with slightly different records in it here. Yeah, and let's first take our inner join, our well-known inner join. Yeah, so if we take so building the inner join, we take the first record here from table R, 10, 100 connected with 20, 100, and 100 equals 100. So this record appears in the result. 10, 100, 20, 100 is the result. If I take 10, 100 and connect it with 22, 102, no, doesn't fit. If I take 11, 101 and combine it with 2100, doesn't fit either. If I take 11, 101 and 22, 102, also don't fit. Doesn't fit. Yeah. So this would be the result of the inner join. The only things that are connected are the two first records here. So the other ones are not connected and therefore are not in the result. And now you see that keyword change here, left outer join. And the idea of the left outer join is simply as follows. Take the same result as the inner join, but also take all records from the left-hand table here that are not connected. So we remember 11,101 is not connected to any record on the other side, and therefore it's not in the inner join. But in the outer join, that's the effect of the outer join. It is, but since it has no connection to table S, we don't have any corresponding values for C and D, and therefore we get null values here. If we take the right outer join, it works the other way around. So inner join again is in the inner join rows. And then we take all records of the right-hand side that are not connected. That's 22, 102. Therefore, we see 22, 102. And we have nulls here for A and B because there is no connection for that record. And last but not least, we have the what is called the full outer join. That takes the combination of left and right outer join. That means take all from the left-hand side that are not connected, take all from the right-hand side that are not connected, and of course take all from the inner join. And therefore we see all three records here. Yeah. So that's that are the outer join. And now let's before I'm going ahead, are there any questions here to that slide?
Professor,
Yeah.
so this outer joint will always constitute one inner joint with him, with that outer joint, isn't it?
That's correct.
Okay. And as we saw in this last table, so when you have full outer joint, then you have means in this case we have two nulls set in the middle row as well as last one.
Yes.
Okay.
Yeah. That's just the effect here that you have to remember how it works. But now we could see how it would solve our problem, namely figuring out who are the non-heads. And I haven't done it here. Okay. So how can us the left join or the right join help with our problem? So so actually we would like to see all employees.
Maybe we can display all the full outer join.
Yeah, we will use exactly, but we don't need a full outer join since we only want to see all employees here, also the non-head. A left outer join is okay. So one thing I would like you to know is that the keyword outer is optional. I could just say left join, right join, and so on. Yeah. So I just do the following. I take a left join, and of course I change that here. Yeah, back. So instead of an inner join as we have had before, so let's Let's start with the query we already had. So these are all the heads. We see all the information about heads, that only those are connected. And now, please take a look. If I add a left here, yeah, then also the remaining ones appear, because so Krause has not been in the output before the left join, but now Krause and O'Brien and Stone and Joe are also included in the result here. But of course, because they are not connected via the head of relationship, there is a null value. Yeah, the outer join must delivers a null value here. And now, in order to figure out who are the non-heads, we combine it with an additional filtering, namely where. And now we take all where all OUID is null. So let's do that. And here we are, Krause, O'Brien, Joe, and Stone. These are the non-heads. Yeah, and since the Krause and O'Brien record, the employee record, are not connected via the head equals EID relationship with the org unit, all columns of the org unit tables within that joins will get a null value. And here we check. And what is important in order that this kind of filtering works is that we take a column that is not allowed to have null values by itself. And I just have taken here the primary key because it always must have a value, it's not allowed to have null values. And therefore, this condition could only be true for those records that are not connected. And now we have the non-heads. Yeah.
Would this query run like instead of where o.ouid is null, like we could say where the name is null?
That would also be possible. We could also say name, yeah, because also that has a null value. And if name has a not null constraint in the table, it would be equally well. Find all unused genres. So the description of all genres that are not related to any title. And we know that that's folk. Folk is the only one. We see here folk has number 4, and 4 is not connected here to anyone here. So please try to build that. So it's the same structure as before. So we take the genre table, left join. That means we get all the genres independent of its connection to titles. We join it with the title table, and then we say, okay, from the title table, the GID should be null, yeah. Or we say the SID of the title table is null, yeah. So here we have taken, Niraj has taken the primary key, and this is always the best solution because it is always not null, yeah. The foreign key on that table is also okay if it has a non-null constraint, of course.
Professor, in Neeraj's query, I did not understand how does it work where TSID is null?
Yeah, so let's
that.
get back that. So once again here. Your question is why TSID equals null?
How does that work for the query?
So there is a actually join is... No, everything is fine, sorry. As you see, we are taking the genre table and performing a left join with the title table.
Yeah.
And if you look at the folk record, so I'm taking here the genre table, yeah? I'm taking here the folk record.
Mm.
And if of course, I'll take all the records, but especially the folk record here. And if I take the folk record and connect it with that table, you see I don't find number 4 here in the GID table.
Yeah.
Therefore, this left join provides the folk in the output, but since nothing could be connected to it here, all the columns here in the result get nulls, and also the SID.
Yeah, but how SID can be null? I mean,
within the table, the SID values don't change; they are there. But if you look at this query, you are not referring to the table, but you are referring here to the join. So if you take, okay, let's do the following. I omit here the where condition, yeah. And if I execute this one here, yeah, and I would take also the SID here, yeah, t.sid,
comma.
Yeah, thanks. Yeah. Oops. What is happening here?
the one you have, the last one has to be removed, I guess. First.
It's executing the statement.
It was a typo. So now we have it. So, who has asked the question? I forgot.
Yes, I did.
Yeah. So, if you take the join here, so this is from the genre table, and this is here from the title table, and within that join here, so you have to take that join here. This is the basis here for the where clause. So, and with respect to that join, you see the SID is zero, is null.
Okay.
In the table itself, of course, it has a number, but here we are applying the where at the result of the join.
Okay.
Yeah, and therefore there is a null in.
If there is no value for it, all the other column values become null for the joint.
So each column from the title table gets a null value here for the folk record.
Okay, so for any column we can write if that equals to null. Okay, I got it.
Not for any. If you would have a column that would allow null values by itself,
Okay.
then it would not be clear if the null is induced by the left join or if it was a null within the table.
Okay.
Yeah. Therefore, in order for that to really work, you must ensure that you only take a column that does not have null values by itself.
Okay. So the null should only be appearing in the join condition. Only then we can take it.
Yeah, the null should be a result of this left outer join.
Okay.
So it's not a null appearing here in the join condition. The join condition is a perfect normal condition. I understand what you mean, where there is no connection.
Yeah.
Yeah.
Okay. Thank you.
Only for those. There should only that those nulls are relevant here. Yeah.
Thank you, Professor. I got it.
Professor, if we here exchange like from genre from table left join to genre, will the results will be same or in
Once
first
again, please.
in first query?
The first here.
Yeah, yeah. Like instead of from table left join genre.
Yeah, we have genre, left join title.
Yeah. So if we swap that like from table to genre, because
From title to genre.
yeah.
Okay. If we would switch that, so let's do that here. Yeah. And let's take this one here. Yeah, because we have the. So if I would say title T here, yeah, and then genre G. That was your question, was it?
Yeah, yeah.
So if I do it that way here, yeah. So let's execute it. And unfortunately, it doesn't work. And the reason is, actually, we would like to see all of the genre table and not all of the title table. But the left join takes all of the title table. So it tells me how to fix that here.
We could use right join in this case
Exactly.
if we want.
So it depends on the order of the tables, yeah. Oops. Let's see. Sorry, I have to. So let's take that once again here, and let's see. From title, where S is null. So this doesn't work.
Professor, the query is ending at GID. There is a semicolon.
I shot myself in the knee. So okay, so let's first take the left join here, yeah, and so once again here, and actually we got no result because every TSID is non-null. Yeah, that's definitely what we would like to have. But if I now change it here, yeah, then we see the fork again. So if I have first the genre and I would like to see all of the genre, then I have to use left join. But if the genre is not the first table here, not the left on the left hand side, but on the right hand side, yeah, then I have to use the right join.
Okay, so starting table we consider it as left and
yeah. So you have to you use the mental picture that everything is in one row.
yeah. Okay.
Yeah.
I tried other ways that I didn't get any results. So
Yeah, I understand. Yeah, that's good remark. This left and right kind of stuff refers to the view that you have everything in one line. Otherwise, it would not really make sense. Yeah, that's right. Yeah.